All right, you guys, I'm just going to do a quick run through, working through all these problems on the review. Feel free to fast forward, rewind, pause, whatever you need to do to get to any of the problems that you don't quite understand. All right, so I'm going to try to move as quickly as I can here. So clearly these first two questions are just proportions, right? So we're just practicing our algebra basically. All right, so I'm going to cross multiply. Remember, it doesn't matter which way you cross first. Right, as long as that equal sign goes in the middle. Now in this one, you've got a lot of binomials going on, right? So when we multiply a binomial times a binomial, right, we do have to FOIL that out. Let me scooch that over. So let's see, on the left, we're gonna get x squared. We're gonna get minus 6x plus x. Well, I'll just write it all out. Minus 6x plus 1x minus 6. And then x squared plus 5x minus 2x minus 10, right? If we FOIL all that out. Let me scooch that over. All right, and then the cool thing about this problem is it looks like a quadratic, but the x squareds would actually subtract and cancel each other out, which is pretty awesome. So that means that I just need to worry about solving for x. So I'm gonna go ahead and combine my like terms on each side and get all my x's together, which of course you could have done that in your head if you wanted to as you were FOILing or double distributing. So that's going to give us negative 5x minus 6 and then 3x and then bring that minus 10 down. All right, so I'm going to add my 5x's over and then I'm going to add my 10 over, which is going to give me 4. And then when I divide by 8, we're going to get 1/2. And there you go. You can always plug your answers back in and double check your cross products and make sure they are in fact equal, right? So everything is checkable there. All right, I'm gonna hop over here. Now this one has a lot going on. So I'm gonna go ahead and distribute here. Let me go down, cross it out down here so I can still see. So that's going to be 3x minus 12. And then this one's going to be 2x minus 2. So I'm just going to go ahead and do that. And then we're right back to the previous problem that we just did, right? So we have our x plus 2 times 2x minus 2. And then our x plus 5 cross multiplies with the 3x minus 12. All right, and then we're gonna do, let me scooch that up a little bit. All right, we're gonna FOIL those out. All right, so that's gonna give us 2x squared. I'm gonna go ahead and combine my middle terms if that's cool with everybody, because I'm gonna get negative 2x and then plus 4x. So that's gonna give me plus 2x and then minus 4. Okay, then on this side, I'm gonna get 3x squared. Then I'm going to get negative 12x plus 15x, which is going to give me 3x and then minus 60. Now, we're not as fortunate on this problem, right, because our x squareds don't cancel, which means it is going to remain a quadratic. So we are going to need to get our equation set equal to 0. I always want my x squared term to be positive when I have to factor. So I'm going to bring all of these terms over to this side to join my 3x squared. So that's going to give me 0 equals, and when I subtract my 2x squared, I'll just be left with 1x squared. When I subtract my 2x, I'll be left with a positive 1x. And when I add the 4, I'm going to have negative 56. So there's my quadratic. It's a pretty easy one to factor, right? Because it doesn't have a coefficient other than the understood 1 in the front. So we're looking for the only two numbers in the world that multiply to give us negative 56, but add to give us positive 1. And that's going to be negative 7 and positive 8. And of course, we're not done because those factors are still set equal to 0. So once we have it factored, we will set each one of the factors equal to 0. And that's going to give us positive 7 and negative 8. And because this is not necessarily a geometry-based question, because there's no diagram to go with it, both of those, of course, would be my solution. Right? Every quadratic has two solutions. It's just a matter of, are they applicable to a diagram or something? But in this case, we're going to use them both. All right, number 3, find the geometric mean of 18 and 24. Okay, so remember we learned all about geometric mean and what it actually means, right? Finding the side lengths of a square that has the same area as the rectangle that's 18 by 24. You don't necessarily have to remember all that, but you do need to remember that anytime you see the words geometric mean, it is a proportion, which is why we learned it in this unit. And so your x's go here and here, and then your 18 and 24 goes here and here. It doesn't really matter where you put those x's and numbers as long as the x's are opposite each other, because we do have to square the x's, and then we do have to multiply the 18 times the 24, right, which is going to give us 432. And that is not a perfect square, so I'm going to go off to the side. Now remember, you can pick any numbers you want that multiply to give you 432, but we literally have 2 pretty big numbers right here that we can use. So why not? You just literally multiplied 18 by 24 to get the 432 in the first place. So let's go ahead and use those guys. And they're nice big numbers, so they're going to break down a lot faster than if I just started with 2. All right, so let's see, 18 is 9 times 2, which is 3 times 3. So I got 18 down to all his primes. And then 24, I'm just going to use 4 and 6. Again, you can pick any numbers. We'll all end up with the same prime pairs at the end, regardless of what you started with. There we go. And let's see, 6 isn't prime because that is 2 times 3. All right, so we've got all of our prime numbers, right? 2 times 2 times 2 times 2 times 3 times 3 times 3, right? That's what gives us 432. So that means x is going to equal, let's see, I've got a pair of 3s. I've got a pair of 2s, and I have another pair of 2s. So I get to take out a 2, and a 3. Multiply all those together. That gives me a 12 on the outside. And then I have the 3, the little lonely 3 that didn't buddy up. He stays on the inside. Technically, this would have 2 solutions, but it only wants the positive root of 432 because we are looking for a number between 18 and 24. All right, moving along. Number 4, if you've done this problem already, you're probably like, man, these are not pretty decimals or pretty numbers. And that's okay. So I'm going to solve for x first. So remember, I'm going to find x. I'm going to find his corresponding side, and I'm going to make a ratio out of that. So x is to 15. Now I'm doing small to big, so you have to make sure you stay consistent, right? If you do big to small, then your other one has to be big to small, right? I'm doing small to big, so I have to make sure I do small to big. So of course, on the other side, I'm going to be using 18. Now you got to be careful, but I can't use the 14 because he's a partial side, so I have to make sure I use the whole thing, right? And I'm going to go ahead and label that as 22, right? So when I'm setting up my proportion, x is to 15 as 8 is to 22. Right, and I don't have any partial sides going on there, so I can just do a quick cross multiplication. So it's going to give us 22x equals 15 times 8, which is 120. Now when I divide that by 22, right, I get this 5.454545 repeating 45. I don't want that, right? We're not going to round unless it tells us to, and it does not. So I'm going to hit math, enter, enter, and just tell my calculator to give me the improper fractional version of that in reduced form, which is 60/11ths. And that is our answer for x. Again, it's not pretty, but it is correct. All right, then I'm going to go find y. Okay, well, let's see. Y corresponds to 16. All right, so I'm going to write that down. So y is to 16, and I'm still doing small to big, so I'm just going to keep that 8/22 ratio rolling from these corresponding sides here that I used on the previous ratio. So that's going to give us, what, 22y equals 128. And when I divide that by 22, I get 5.81818181, so another repeating decimal, right? But I'm just going to hit math, enter, enter, and my calculator tells me that that's 64/11ths, which of course you can see, right? We're just reducing the fraction by 2. All right, I'm going to write that guy over here. All right, let's see. Next up, I'll use blue. We're looking for z. Okay, well, z corresponds to the 12. So I am going to do z is to 12. And again, I'm still going to use that 8/22. All right, so let's see. We're going to get 22z equals 96. And we're going to divide that by 22, which, what do you know, gives us another repeating decimal, right? But I'm going to hit math, enter, enter, and it's going to reduce that for me to 48/11. Okay. Then the last one is it wants us to find A. That is referring to angle A, by the way, right? And so we know that similar figures have congruent corresponding angles. So that means A is going to be the same as his little corresponding buddy up at the top. So 140 degrees would be his value. All right, number 5, the ratio of the base length of the height of a triangle is 2:3. The area is 24. Find the length and base of the triangle. Okay, we'll learn better ways to solve these questions next 9 weeks, but we're gonna go ahead and roll with it here. So it says the ratio of the base lengths of the height of a triangle is 2:3. Okay, so it's base to height. Okay, I'm just going to kind of do this. Here's my height. There we go. All right, so base to height, so 2x to 3x, right? That's essentially what that's telling me. Now, remember, we can find the area of a triangle by doing 1/2 base times height. Okay, well, if my base is 2x and my height is 3x, because it's in that ratio, right? I'm going to go ahead and simplify that as much as I possibly can. Now, right here, of course, half of 2 is 1, so I'm just going to go ahead and take care of that 1/2 right there. So it's just x times 3x is all that's left, which is 3x squared. Okay. All right, well, what am I going to do with that? Well, they told me right here that the area is 24, and I just found this awesome expression that represents the area. So I'm now going to set, 3x squared equal to the 24. And I'm going to solve that equation. Now, it only has a single x squared in it, so it is a quadratic, but that's okay. All right, we're going to go ahead and divide by 3 on both sides. And then we're going to square root, and we only want the positive root, and the square root of 8 is 2√2. All right, so that would be the value of x. Lovely. All right, find the lengths of the base and the height. Okay, well, the base was 2 times x, so 2 times 2√2, which is 4√2. Remember, you can only multiply numbers outside times other numbers outside, and numbers inside times other numbers inside, and that would be meters. And then we have the height of the triangle, which was 3 x's, so 3 times 2√2, which is 6√2. That doesn't give us an area of 24. Hold on one sec. What did I not do? 1/2 base height. Oh, it is. I'm sorry. It didn't take half. Oh my goodness. I'm losing it. I was like, I don't see a mistake. All right. So that's it. That is correct. Right. And we can check our answer. Sorry, I was freaking out there for a second. Right. Because if we multiply this base times height, right, 4 times 6 is 24, but square root of 2 times the square root of 2 is 2. So 24 times 2 is 48, but we're doing a triangle. So it's half of 48, right? 1/2 base times height, which does give us 24. Sorry, I always like to check my answers as I'm going. All right, yeah, that was a tricky one. All right, number 6. The measures of the angles of a triangle are in a ratio of 4 to 5 to 6. Okay, well, we did this last unit, right? So again, I don't really know exactly what the triangle looks like, and it doesn't really matter. Remember, our ratios are multipliers. We did that same thing right here. They gave us a ratio, so we just made it a multiplier. So we're going to do the same thing here. So 4x, 5x, 6x, and those are angles of the triangle, right? So that's going to tell me that 15x, using our triangle sum theorem, we know that the angles have to add up to 180, right? And when we divide 180 by that 15, right, we get 12. So that means I can plug the values in, and that means my smallest angle is going to be 48 degrees because 4 times 12, right? My middle angle is going to be 60 degrees because 5 times 12, and then my largest angle is going to be 72 degrees. And of course, you can check your answer by making sure that those add up to 180, and they do in fact do, right? And so that is our answer. All right, number 7. All right, so these are similar figures, and we can prove that because we have one pair of congruent angles right there, and we also have this lovely pair of vertical angles. So I can prove by AA similarity, I know it's not asking you to do that, but I'm going to go ahead and write it. I can prove by AA similarity that these are similar figures, which means that they are proportional, right? Now I'm going to highlight all the corresponding sides. This one's kind of tricky, so you want to be really careful. You'll notice, I'm hoping, that this is a mirror image of itself, right? It's like flipping over, right? So this is not a reflection, and I can tell that because of the context clues of my similar or my congruent angles both being at the bottom. So if my congruent angles are both at the bottom, then that automatically tells me that the 8 and the y are corresponding sides, right? Because of their reflective quality, okay? And I'm going to go ahead and highlight everybody else just to kind of stay consistent. So the 6 and the 9 go together, and the 10 and the x go together. So when I set up my proportions, right now I have all my lovely values that are corresponding, so I don't mess that up. Please just make sure that you go in I don't care how you set up your proportion, as long as you're consistent, right? I'm going to do small is to bigger one, so I'm doing left to right, which means I have to go back and do left to right. Right, 10 is to x, a 6 is to 9, right? I'm doing here to here, here to here, right? So your movement has to stay consistent. You just can't hop around anywhere you want. So no matter how you set yours up, we should all still have the exact same cross product, right? Because when I cross multiply, I get 6x equals 90. And you should too, no matter how else you set up your proportion. If it was different than mine, we should still get the same cross product, right? So 90 divided by 6, right, to solve for x. So we're going to get x equals 15. And then, of course, to solve for y, we're going to do the same, right? I'm going to do the same movement. I'm going to do 8 is to y. You don't have to move the same way I do, but if I do 8 is to y, left to right, I have to do 6 to 9 again, right? Erase. All right, and then just cross multiply. We should all be getting 6y equals 72, which gives us y equals 12. All right, this next one on number 8, this is clearly telling us to use the angle bisector theorem because of the angle bisector happening there. And remember, the angle bisector theorem tells us that this side is to his little corresponding part over here, as this side is to his corresponding part over here. So while I love that they gave me this 20, that is not part of the angle bisector theorem, but they gave that to me because I have to clearly use the 20 to figure out that this side is 12, right? Because I have to have those two pieces. If I don't, well, then I can't use the theorem, right? Unless I have enough information to write some sort of expression there. So our proportion is going to be x is to his 12, as x minus 5 is to the 8. All right, and so we are going to, let me get a darker blue, we're going to multiply across, so 8x. I'm going to go ahead and just distribute my 12 to the x minus 5. Make sure you go to both the x and the 5. And let's see, that's going to give us negative 4x equals negative 60, which will give us positive 15. Remember, it's difficult to check these problems because you're depending on the fact that you are getting the correct proportional relationship, right? So can I plug it back in and check to see if 15 works? Sure, but you're banking on the fact that your proportion was right in the first place, right? So you got to be super careful with these. All right, on number 9, there's 2 different ways you can do this problem. You can do the proportionality theorem, which says this is to this as this is to this, in which case you would need the algebraic expression x minus 4 to represent that piece. That is the proportionality theorem, right, of parallel lines. So you can do it that way if you want to. Notice you're doing whole side to whole side and then partial to partial. Right? That 12, that is not the full side of a triangle. That's a partial side, right? And it's okay to use partial sides as long as you're using a partial side on the other one, right? So whole to whole, partial to partial, that's consistent and that's okay, right? So you can either solve it that way. Actually, you know what? I'm going to leave it there. So I'm going to write them both. I can say 3 is to 4 as 12 is to x minus 4, right? So that is one possibility. Or I'm going to solve it the other way. If you don't ever want to use partial sides, you don't have to, right? I can say 3 is to, and then make sure I get the whole side over here, which would be 15. So 3 is to 15 as 4 is to, and they gave me the whole thing being x. All right, so I'm doing full side is to full side as full side is to full side. I'm not using any partials, so I'm staying nice and consistent, right, with my side lengths. So either one of these proportions is going to give you the correct answer for x. Okay. All right, I'm just going to solve the bottom one because it's easier. I don't have any binomials, so I just get 3x equals 60, so x equals 20. All right, whew, that took me a long time to get through that first page. All right, I'm gonna try to pick up the pace a little bit. Let's see, number 10, this is also a proportionality theorem, right? That literally just says that the pieces between the parallel lines must also be proportional. So 21 is to 18 as x is to 12. Now I went left to right, left to right. You can also go top to bottom, top to bottom. Well, it gives you the same proportion or the same cross product, so either way is fine. All right, a quick solve. I feel like doing that in my head. 21 times 12, so 252 divided by 18. I am getting 14. All right. All right, this one is super fun because it's clearly an angle bisector problem, which means this side, right, is to his 8 as this side is to his 10, right? So that's how that theorem works out. However, they did not give us this side or this side, right? But they did also tell us that the perimeter is 54. So if I add up all the sides, I get 54. Well, they didn't give me enough information for that to help me either, which means I'm going to have one of them be x and one of them be y. I don't have any way around that. So this is going to be a systems problem, right? So I'm going to use my x and y in my angle bisector theorem to set up my first proportion. So x is to 8 as y is to 10. Okay. Then I'm going to use my perimeter equation to say that x plus y plus 18, because that's the whole bottom, is 54. So this right here is our system, right? Those are the two equations from totally different relationships, right, that are on this triangle, but we're going to use those two equations against one another to solve for x and y. Now, obviously, I'm not going to leave that top guy as a proportion, right? I'm going to cross multiply and get 8y equals 10x. If you're a person that likes it in standard form because you're going to do the elimination property, then you're probably going to want to subtract. I'm going to subtract the 10x to the left side, and that's going to give me 0. And then I'm going to do my x plus y equals, right? And I'm going to subtract the 18 from the 54 to move the constant over here. And now I have my two equations in standard form. So now I can solve by the elimination method. You could also use substitution method here. That would be a great time to use that. It would be pretty easy. Let's see, I'm going to go ahead and multiply my bottom equation by 10 because I'm just going to cancel out those x's. So that's going to give me 10x plus 10y equals 360. And just for the sake so I don't lose anybody, I'm going to rewrite my top orange equation. I'm trying to stay color-coded here. All right, there we go. Those will now cancel. I'm sorry. And let's see, if we add our y's, we're going to end up with 18 y's equals 360. So y is going to equal 20. Oh, I didn't even notice. Sorry, guys. I didn't even notice that it would ask for AD. And this is why you should look ahead to see what the problem's asking for, right? So it does want AD, which I have labeled X. So I should have canceled out the Y's and solved for X, but that's okay. So now that Y is 20, I'm just going to plug him in anywhere. Like you could literally plug him into the perimeter formula. And I'll just do that. So if the perimeter is 54, I'm going to subtract the 18, and then I'm going to subtract the 20 that we just got. And that leaves us with x equals 16. Right, so just plug your 20 back in. I could have made that a little easier on myself had I read ahead there. Okay, that was a fun one. All right, hopping over here. The first thing I notice is I have parallel lines, which means I'm going to do some markings here, right? I know this alternate interior angle is congruent to this alternate interior angle, and this alternate interior angle is congruent to this one. So I know these are similar by AA similarity. You could have also used the vertical angles, of course. The reason why I marked the alternate interiors is because I do want to notice that these two triangles are rotations of one another, right? So that means, of course, the 49 and the Y correspond to one another, but the 35 corresponds to the X, right? Because if I were to spin it around and rotate it, those would be the two that lie on top of each other. And then the 42 and the 24 correspond, right? So you just want to use those context clues to make sure you're setting up your proportion correctly. All right, so if I want to solve for X, I know X corresponds to 35. Now that means I went little to big, so I have to go little to big, and I'm going to use 24 over 42 when I set up the other side. Okay, again, consistency is key, right? If you want to do big to little and go top to bottom, right? Either way, we should all end up with the same cross product, right? So that's going to give us 42x equals some big number. Let's see, 35 times 24, 840, right? We're going to divide by 42 and get 20, okay? So x is 20. And then, of course, I'm going to do the same thing for y, right? Y corresponds to 49. And I'm going to go ahead and use that same 24 to 42. And again, I'm going small to big triangle, right? So just keeping that consistent. All right, so let's see. I'm going to get 42y equals 1176. Right, I divide by 42 and I get 28 for my answer for y. All right, moving right along. Okay, on this one, they're telling me, this is a tricky one. There was one like this on your homework, right? So here we go. BD or DB bisects ADC. Okay, so these angles are congruent, which means I have an angle bisector, which means I'm going to use the angle bisector theorem. So let's refresh, right? Remember, the angle bisector theorem says that this side is to his little corresponding part over here, as the 12 is to his little corresponding part over here. Well, we have a big problem, right? Because they've labeled this X, which is great, but I don't know what this is. And they didn't tell me the whole thing, right? So I have a problem, which means I'm like, well, I need to know what the whole thing is, because this piece is going to be, you know, whatever that is minus X left over. So you have to ask yourself, how am I going to be a clue finder and figure out how to find the length of that whole big side? Well, the key to this problem is to notice that it is a right triangle, right? And right triangles means I can use the Pythagorean theorem to figure out what the length of that hypotenuse is. So that is what I'm going to do. We'll be talking a lot more about Pythagorean theorem in Unit 5, but here it is again. So leg squared plus leg squared. So the two legs of the right triangle are 5 and 12. The C is the hypotenuse, right? So when I say C, I'm talking about this whole length. Let's see, when I add 5 squared plus 12 squared, I get 169. And then when I square root, I get positive 13. Well, the positive 13 is the only one I want. Awesome. All right, so that very first step now tells me that this whole thing is 13 from here to here, which is awesome because now I can write that this BC length must be 13 minus X. All right, without that, I would not have been able to figure that out. All right, now we can set up our proportion, right? So 5 is to X as 12 is to 13 minus X. All right, so just a quick little cross product. Let's see, we're going to get 12x equals 65 minus 5x. All right, so we're going to add the 5x, which gives us 17. That's not going to be a very friendly number, is it? So 65 divided by 17. It's this big, long, gross decimal, 3.82352, blah, blah, blah. We don't want that. So a quick little math, enter. And it's not even reducible either, but my calculator reminds me that it's just 65 fifteenths. Oh, 17ths, sorry. All right, moving on, number 14. Let's see. There's a few different ways you can do this one. It's very similar to number 9, where we talked about the different ways, whether I want to use partial sides or not. So that's just kind of a personal choice. I am going to go ahead and use partial sides this time, because if I do 12 is to 10, 12 is a whole side and 10 is a whole side, right? But 3 is a partial, and so is y. So as long as I'm doing whole is to whole as partial is to partial, that is consistent. Or you can do this way, whole is to partial as whole is to partial. It doesn't matter, right? We'll all end up with that same answer. So I'm going to go ahead and just do it the way I had it initially, right? And just go top to bottom, top to bottom. So 12 is to 10 as 3 is to y, right? So 12y equals 30. Right, and when I divide 30 by 12, I do get an exact decimal. I'm just going to write that down. I get 2.5. If you want to write your answer as 5 halves, then you are more than welcome to do that. All right, now x is a totally different story, because x is a full side of the small triangle, and 8, his corresponding side, is a full side. So when I'm setting x is to 8, that's full side is to full side, so I have to make sure I am doing the same thing on the other one, right? So I would have to use, so I'm gonna go back to my highlighter. So I'm doing small to big, so then I would need to do small to big, right? It has to be entire sides, right? Small whole side, small, big whole side, and then the same thing on the other triangle. So I would have to use 12 to 15. I cannot use the 3 because the 3 would be the only partial side in my proportion, and I can't use a proportion with only one partial side. All right, so we're going to cross multiply. So I'll just do the 15x. equals 96. And when I divide that by 15, I also get a decimal, but it's nice and finite, right? So I'm going to write 16.4. If you want to write 32/5 and write it as an improper fraction, then that's okay too. All right, number 15, they're telling you that ABC is similar to EFD. We love it when we are given the similarity statement because that means I can highlight and I can be like, okay, that means A and E correspond and B and F correspond. Oh my goodness, I'm so glad I looked at this statement, right? Because these are clearly rotations of each other and I would never have known that if I wasn't paying attention to the congruency statement. All right, so C and D are both the third letters, so that means they must correspond. So that's really tricky, right? So you want to be super careful there. All right, so let's see if I'm solving for X. Okay, well, X corresponds to the other one between the pink and the orange, which would be the 12, right? So X corresponds to 12 as, sorry, I'm going to put let me use gray there. Let me pick a different color. I'll just use bright orange. Let's see. I can't use the Y, which means I can't use the 15. So I'm going to have to use the 10, which is between the pink and the green, and the 6, which is also between the pink and the green. So 10 is to 6. X is to 12 as 10 is to 6. And I'm using all my wonderful context clues to make sure I'm using corresponding sides. All right, so that's going to give us 120 equals 6x. So x equals 20. All right, and then of course I'll be able to now use my 15 to y. I'm going to just go up here. So 15 is to y, and then I'm just going to use that 10 is to 6 again. All right, so we're going to get 90 equals 10y, so y equals 9. All right. Remember, if they're giving you this, it's for a reason, right? If they're giving you that similarity statement. All right. Oh my goodness, 2 more of these. Okay. So this is very similar to number 14 that we just talked about. I noticed the parallel lines, so these are definitely similar figures. I'm going to use the shortcut proportionality theorem that says I can just hop straight across and use partials, right? Whole is to whole as partial is to partial, and that's consistent, right? So I'm just going to do it that way. 6 is to 8 as y is to 12. All right, so we're going to get 72 equals 8y, so y equals 9. Now, x, unfortunately, is a totally different story because x is that whole length, and he corresponds to this whole length, which means if I'm doing whole is to whole, and then I pick this side, which is also the whole side of the smaller triangle, I have to make sure I'm picking the whole side over here. I cannot use the 12 because he would be my only partial in the proportion, and I cannot just have one partial side in a proportion because that would mean that my entire problem is completely inconsistent with itself. So let's see, x is to 26, so I'm doing small to big, as 8 is to 20. So 20x equals 208, and then I end up getting 10.4. which is a nice finite decimal, so I'm totally fine with that. Again, if you want to write that as 52/5, I would take that also. All right, last one on this page, another angle bisector theorem, right? Which remember, the angle bisector theorem stays, it's the same thing every time. It says 36 is to his little partial side as 27 is to his little partial side that's attached to him. Well, clearly I don't have an expression for that little piece that's attached to the 36, but I do have enough to find it since they told me that that was 42. So this must be the leftovers of 42 minus x. And now we can set up a proportion. So 36 is to 42 minus x as 27 is to x. All right, just do a quick cross product. Let's see, 42 times 27. 1134 minus 27x. So I'm going to add my 27x's to the other side and then divide by 63. Oops. And I'm getting 18. There we go. Whew, that was a lot of work on those first 2 pages. Okay, take a little break here with a little less work. All right, so proving if they're similar or not. Okay, well, obviously the only information I have on these 2 triangles is side, side, side. So if they are proportional or they are similar, then my sides would all have to be proportional. So we are going to check and make sure that that's actually happening. So it does look like these are just translations or shifts of one another. So it looks like the 8 corresponds to the 12 or the 20, the 12 corresponds to the 30, and the 10 corresponds to the 25. But I do need to check to see if those are proportional. So I'm going to set up a little extended proportion, right? And it's going to have little question marks technically, right? Are these side ratios proportional? So I'm just going to do 8 is to 20, or you can do 20 is to 8. I don't really know why I'm going that direction, but that's okay. 8 is to 20, as 12 is to 30, as 10 is to 25. And of course, the easiest way to check to see if all of those are in fact equal is just to reduce them. So 8/20ths reduces to 2/5, and 12/30ths also reduces to 2/5. And what do you know? 10/25ths also reduces to 2/5. So yes, all the sides are proportional. So yeah, I'm going to put just yes. And this would be side, 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 similarity. Please make sure you put the similarity symbol because we need to make sure that we know that it's different than side, side, side congruency theorem that we did in Unit 3. All right, number 19, clearly the only thing they gave us was angles. So if these are similar, then angle, angle would be my only option, right? So I am going to use my lovely triangle sum theorem, and I'm going to subtract 68 and 62 from 180 to see what's left for this little top guy, and he is 50 degrees, which means this guy must be 62. And it looks like all my angles are congruent. So yes, by angle, angle similarity. Please don't write AAA, right? The theorem or the postulate's called angle, angle, because if 2 angles are the same, then the third angles are automatically, so it's kind of redundant to write that. All right, let's see, next up, these questions. Okay, we've seen this question 3 times now. This is a tricky one because you could either see this because there's no parallel line marks or anything like that, which is problematic. So I can't tell if this is a rotation of itself or a reflection of itself. So whichever way you see this picture determines whether this is a yes or a no. So if you see this as a reflection of itself, then that means you see the 4 corresponding to the 10 and the 6 corresponding to the side, to the 15. Now, obviously, the vertical angles are congruent, so this is an SAS situation if those are similar. So I'm going to say, is 4 to 10, is that equivalent to 6 to 15? And yes, because their cross products are both 60, or you can reduce them both to 2/5, right? Either way. Right? So if you see this as a reflection, then our answer is yes by SAS similarity. If you look at this picture and you see it as a rotation, well, then your 4 would be going to the 15 and your 6 would be going to the 10, in which case you are going to get 40 equals 90, and that is not equivalent. So you would be saying no. Okay, so I would take either answer on that one. So I'm just going to put I'll just put a little note, or no if rotation. Okay. All right. Lastly, over here, they don't tell you which sides correspond, but we can just use our logic to recognize that 12 is the shortest side of that triangle, which means he has to correspond to the 18. Right? Because if we have similar or proportional figures, right, then a small side goes to small side. And then, of course, 14 is the second smallest. So he would have to go with the 21. and then the longest side would have to correspond to the longest side. So when I set myself up a little extended proportion to see if those are proportional, right? So is 12/18 equivalent to 15/24 equivalent to 14/21? Right? And you can probably tell without actually having to write this that that's a big no, right? Because 12/18, right, reduces to 2/3. Well, so does 14/21, right? But 15/24, that reduces to 5/8, right? And 5/8 is not equal to 2/3, right? So this is a no. And you would just leave this blank, of course. All right, let's get to a couple of word problems here. I would suggest drawing a picture if I were you. So it says a woman 5 feet tall. Okay, I'm just going to draw these two triangles separately. You could draw them inside of one another if you wanted to. All right, so here we go. A woman 5 feet tall. There we go. Casts a shadow 4 feet long. Oh, I did not draw that to scale, but that's okay. All right, and then at the same time, a nearby lamppost. I assume the lamppost to be taller than the woman. All right. The lamppost casts a shadow that is 9.6 feet long. How tall is the lamppost? Now, we do assume these to be similar. In this class, everything we do is going to be standing perpendicular to the ground. So we assume that the woman isn't leaning, and we also assume the lamppost isn't leaning off to the side. All right, so that's a pretty easy little proportion there, right? Just stay consistent. All right, I'm going to say 5 is to x, so I'm doing height is to height as shadow is to shadow. All right, again, you can set your proportion up differently than mine as long as we have the same cross product. We're all good. So when I solve this, we're going to get 4x. Oh, sorry about that. Let's see, 9.6 times 5, 48. So x is 12. And I want to make sure that I include feet because story problems or word problems should always have units attached to them. All right, so a builder sketches plans for a room using a scale factor of 1 to 18. All right, so keep in mind what this means, right? 1 to 18 means that the actual room is 18 times bigger. 18 times bigger. Now we could set this up as a proportion, but I'm just not. So, but you're more than welcome to. It says in the plans, the room is only 1 foot by 8 foot. Well, of course it's only 1 foot by 8 foot on the plans, right? Because it's just a tiny little sketch of the plan. All right, well, what am I going to do to these actual measurements? I'm going to multiply them by 18 because the actual room is 18 times bigger, right? Because they literally just told us that, right? So that means the new dimensions are going to be 18 feet by, I don't need that, 27 feet. And we're not done because it asks for the actual area of the room. Well, remember, area is just base times height, right? So we're just going to multiply 18 times 27. And we get 486. Uh-oh, what happened? And remember, it's area, so we hop up a dimension, right? So square feet. All right, looks like we're getting into our transformations here. So let's see, it says we're going to graph the dilation. Now, this problem is awesome because the dilation is centered at 0, which literally means whatever the scale factor is, we can just apply the scale factor to the original points, right? Oh, I'm pulling it back halfway. That means all of my coordinates are just going to be cut in half, which means A prime would be at 4, 2, right? Because I'm literally just dividing those guys by 2. Right, B would be at -4, -1, and C would be at 1, -3. And you should graph it over there, by the way. Now, again, the only reason why that's easy like that is because you're centered at the origin, right? If you were centered anywhere else, you would not be able to do it that way. You would have to actually draw it and then analyze your movements and cut your movement from that new center in half. Okay. All right, this one we're doing a translation, right? So they're giving us the mapping rule. So remember, +5 just means we're going right 5. And then the -7 on the y means we're going down 7. So every point is just moving right 5, down 7. Of course, you can either graph that over here and then apply the movement, or you can literally just do what it's telling you to do and add 5 and subtract 7 from every single one of these points, right? Add 5 minus 7. Add 5 minus 7. And then write down your new points, right? So our A prime would be at 0, -1. Our B prime would be at 1, -7. And our C prime would be at 3, -3. Okay, and you can plot that. All right, number 26. We have triangle ABC, find the coordinates after a reflection across the y-axis. All right, so I'm just going to plot 1 point because let's say maybe you forgot the rule, right? Because reflecting across the y-axis definitely has a very specific rule and pattern that belongs to him. If you happen to forget what that is, don't worry. All right, you can just go ahead and go to your graph and plot -3, 4. So here's my original A right here. And then here's my line of reflection, right? Because they want me to go over the y-axis. Well, that means I'm just going to count the mirror image. It looks like A is 3 units to the left of my line, which means his reflection buddy is going to be on the opposite side, 3 units to the right. Now, this point is -3, 4, but this point is +3, 4. So if you need to do that to just help you remember the rule, like, oh, that means the x's become negative and the y's stay the same. Okay, so that is our rule. X's are negated and y stays the same. So A prime is at 3, 4, and you can just graph the whole thing if you need to. Obviously, -0 is still 0, which makes sense because 0, 7 is on the line of reflection. 1, 2, 3, 4, 5, 6, right? If I'm on the mirror, then it's not going to move. And then, of course, C is going to be +1, -2. All righty. Let's go do some y equals x. So they want us to use the same A, B, and C. So make sure you go back to the originals. Don't use the new guys, right? So they want us to go over the y equals x line. Okay, well, again, if you don't remember the rule, you can just graph the y equals x line, right? And do the reflection over that if you want to. But the rule for y equals x is really easy because literally it's saying that y equals x and x equals y, right? So they just swap. Right, so all we're doing is just swapping the A's, B's, and C's. So for A prime, that would become 4, -3. And this would become 7, 0. And this would become -2, -1. Then they want us to go over the y equals -x line. Okay, so So our rule, it's basically the same, except it's y equals -x, which means everybody is flipped and negated, right? We still have to swap because you're still going over a y equals x line, right? But it's the negative line, so everybody becomes negative. So let me see, I gotta go back up here. So -4, 3, right? If we switch and negate everybody, and let's see, what was B again? 0, 7, so -7, 0. And then C was -1, -2. So he's going to become +2, +1. And you can always graph it, right? To just double check and make sure that that looks correct. Okay. All right, moving on to some dilations here. All right, we did lots of these problems. First thing we're going to do is let's find the scale factor. All right. some of this, we are assuming that these points are nice and perfect on the corners. So if it doesn't look like it's hitting a corner perfectly, just, it should be. All right, so we have C and D. So we need to analyze the movement from C to D and C prime to D prime to see how that changed. So please remember that scale factor, let me write this down. Scale factor is always new to old. Right? So I'm just going to analyze the vertical movement. Who cares? It doesn't matter. So I'm going to do the vertical movement here from C prime, D prime, which is my new one. So that has a movement of 3. But my old movement to get from C to D is 6, which means my scale factor is 1/2. Right? Again, I'm analyzing 3 to 6. If you want to do the horizontals, the horizontal movement is 2 to 4, so you're still going to get 1/2. So it doesn't matter if you analyze the vertical movement or the horizontal movement, we're all going to end up with 1/2, which makes sense, right? Because I cut all the movements in half, and my new image is clearly smaller than the original one. All right, so now we need to find A and B. Okay, well, I'm going to analyze the movement. Let me get a highlighter. Of DA, and whatever the movement from D to A is, I'm going to cut it in half. So it looks like we went down 1, 2, 3, 4. That's not really on the line there. I went down 4 over 4. Okay, well, I'm going to cut those movements in half. So I'm going to go down 2 over 2. And this should be the new location of A prime. And let's see, what is that? 1, 2, 3, 4, 5, -5, 2. All right, then I'm going to go find B. So I'm going to, and you can either use, I'm going to just use CB, just because that's easier than for me anyway. So let's see, how did I move from C to B? Okay, well, I went right 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6, 7, 8. So I went right 6 over 8. I'm going to cut those movements in half. So I'm only going to go right 3, down 4. And that should be my new location of B. Which puts me at -2, 3. Okay. If you want, I would highly suggest that you actually draw your new image, right? If I connect C prime, my C prime with my B prime, with my A prime, with my D prime, right? I end up getting this image right here. And does he look exactly the same as this image right here, just a smaller version? Yes, right? And if it doesn't, well, then you've put a point in the wrong spot. Okay, number 30. We've dilated it. Clearly, it's gotten bigger, all right? So we just need to figure out how much bigger. Okay, well, the first thing I need to do is find that scale factor. So I'm going to analyze the movement of AC, that's the original, to the new AC. Okay. So I moved right 2. Okay. Well, on this one, I moved 2, 4, 6. I went right 6. Right? So if I'm doing scale factor, if I'm doing new to old, that would be 6 to 2. Oops, sorry, I was thinking ahead. Which is 3. So this is a scale factor of 3, clearly, because we've gone 3 times further. Okay, so now that we have a scale factor of 3, we need to find the location of B by applying that same concept. So AB, let's go analyze those movements. We went left 1, down 4. Okay, well, I'm going to triple all of those movements. So instead of going left 1, I'm going to go left 3. And instead of going down 4, I'm going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 puts me right here for my B prime. And again, I'm going to connect my vertices, A prime, B prime, C prime, and I want to do a quick double check, right? Is the new triangle that I've just drawn with my new B prime, does he look similar to the one I started with, right? And yes, he does, right? So I'm pretty confident in my answer. Let's see, what is that ordered pair? 1, 2, 3, 4, -5, -5. What was the scale factor? 3. We already talked about that. How do the sides of the figures compare? They are proportional. How do the angles of the figures compare? Well, they're triangles, so it doesn't matter how big or small they are. The angles have to add up to 180, right? Which means the angles are congruent. Oops. They are congruent. And of course, when I say they are congruent, I'm talking about the corresponding angles being congruent. All right, number 31, which transformation would not be rigid? Right, remember, rigid means that it stays the exact same size and shape. Well, that means dilations, right? Dilations are non-rigid because they can affect the size and shape. All right, number 32, rotate the triangle about the origin. We always go about the origin. If you happen to forget this rule, I'm going to show you the long way about that, but this is the way I always do it because I always forget the rule. So remember, we're trying to do a 90-degree rotation with the origin. So I'm going to do point C, which means I'm going to draw a segment from the origin to C, and I'm going to analyze that slope. So I'm going 1, 2, 3, 4, 5, 6. I'm going up 6 over 2. Okay, so he has a slope of 6 halves. Now I know that that's 3, but I'm not going to reduce it. All right, so 6 halves is the slope from the origin to C. Well, a 90-degree rotation means that I need to create a 90-degree angle at the origin, right? So right here has to be a 90-degree angle. Well, what do I know about 90-degree angles? They're created by perpendicular lines, and perpendicular lines have opposite reciprocal slopes. So I need to figure out where is C over here somewhere, right? I know it's got to be over here. That has the opposite reciprocal slope. Well, the opposite reciprocal slope of positive 6 over 2 would be negative 2 over 6. So I need to figure out where the location of the line would be that has a slope of, if I went down 2 over 6, I would hit the origin, right? And that would be right here, right? Down 2 over 6. And I know that that is a perfect 90-degree angle because of the opposite slopes. Now, I know that's a lot to think about, right? But it's, if you happen to forget the rule, right, this will help remind you of that rule, right? Because let's see, what is C? 1, 2, 3, 4, 5, 6. So the original point C was at 2, 6. And look at my new point C, right? This is C prime, and he's at negative 6, 2. Oh, well, what happened? Oh, I flipped the coordinates, right, and negated the old y coordinate or the new x, however you want to think about that, right? So sometimes you just forget the rule, and if you just know how to think about it the long way, right, then you can refresh yourself and discover the rule again all by yourself. So negative yx, negate the y, switch the coordinates. So I'm just going to do that from here on. So I already know C is negative 6, 2, so I may as well throw that in there. Let's see, point A is, I'm just going to write this right here. So point A is at 2, 1. All right, well, that means I'm going to negate the y and then switch. So the negative 1's going to come here and then the 2. And you should plot it, right? Negative 1, 2. Does that make a right angle with the origin? Yeah, it does. And I'm going to go ahead and throw the B down here. What's B? 1, 2, 3, 4, 5, 1. So again, I'm going to negate the y and flip the coordinates. So it's going to become negative 1, 5. And again, I can totally check that on my graph, right? Negative 1, 1, 2, 3, 4, 5. Yep, looks like a right angle. Okay. All right, number 33, we're going to stretch by a factor of 4 vertically and 2 horizontally, and then reflect. Oh my goodness. All right, there's a lot going on here. All right, So here's what I would do if I were you. I'm not really going to do any of my work on the graph. You're totally more than welcome to, but I'm just going to go ahead and just use the coordinates, -2, 2. All right, so I know for the first transformation, they want me to multiply the 4 vertically. Now, please be very careful because vertical is a Y movement, right? They're trying to be very tricky here, right? So we're going to multiply the Y's times 4. Here, it looks like an X. Let me do it. So this is going to be 4Y, right? And then 2 horizontally. Horizontal is an X, so all my X's are going to get doubled. So we're doubling the X's, quadrupling the Y's. Okay, so that's going to give us, let's see, we're doubling the X's, so -4, quadrupling the Y's, that gives me 8. Okay, I'm gonna do the same thing with the B. Let's see, where's B? 2, 1. Okay, so B prime, right? We're doubling the X, quadrupling the Y, so 4, 4. And then lastly, let's see, where is C located? 0, -2. Okay, so we're going to double the X, which is 0, so he doesn't go anywhere, and quadruple the Y, so he becomes 0, -8. All right, so those are all my first locations. So -4, 8, 4, 4, and 0, -8. So I'm just going to go ahead and write those in up there. All right, but then we're going to reflect over the Y equals -X line. Well, we just talked about this, right? I'm going to go ahead and write A double prime, B double prime, C double prime, right? So remember the rule for reflecting over the Y equals X is all of our XY's become -Y, -X's, right? They have to switch and negate. All right, well, I'm going to do all of that to these guys, right, because I'm transforming my new spots. So let's see, if I flip and negate, the -8 comes first, and the 4 becomes positive when I flip it. And then I do the same thing here, and my -4s become -4s. Technically, they're swapped, but it's the same number. And then my +8 moves to the front, and of course, my 0 negated is still 0. And voila, there's our new point. All right, whew, that's a long review. Number 34, dilate triangle DEF centered at point E by a scale factor of 2. Okay, so notice we're not at the origin, which means we just can't double the coordinates, right? We have to actually analyze the movement, and we're centered at point E. So that's like our little flashlight. Remember us having that conversation? So we need to double everybody's distance from E is essentially what that's saying. All right, well, if I double everyone's distance, well, let's see. How did I get to D? I went left 4, down 2. Okay, well, I'm going to go left 8, down 4 then, and that's going to put me here. Make sure you don't do it twice, right? I want that movement and then another movement, right? Because that's 2 times further from E than D was originally. Okay, what about F? Looks like we went right 2, down 1, 2, 3, 4, 5, 6. So instead of right 2, down 6 for me, I'm going to go right 4, down 12. Which should put me here, I believe. All right, and if I draw and connect everybody back to E, because clearly E is not going to move since he is the point of dilation. Right, and we had this conversation too in class about checking our dilations, right? Remember, all of your original points and their primes, they should all lie on the same beam of light, right? So if you accidentally, on your test, right, if you accidentally move F and he's like over here, well, you should be like, something's wrong because they're not collinear, right? They're not sharing that same light beam. All right, so just a quick little write-up of here. Let's see, D is now at -60, or D prime, sorry. Sorry, E prime is going to stay put, so he's at 2, 4. And F prime is what, 6, negative 8? Okay, there you go, scale factor of 2. All right. The last few questions here are covering those just like random triangle facts that we did on day 5. All right, so here we go. Longest side. Well, remember the longest side lies opposite the largest angle. Now, obviously, we want to fill in all. We want to have all the angle measurements filled in. These clearly add up to 150 degrees, which means this guy is 30 degrees. I'm sorry. I don't know why these don't have little degree marks on there, but they should. Degrees. There we go. So let's see. That means the longest side. Well, 80 is my largest angle, right? And he is the angle that is driving how long AC is, because AC is the one that has to close up the 80-degree angle. So that makes AC our longest side. And of course, our shortest side must lie opposite the 30-degree angle. Again, please notice that these pictures are not drawn to scale, right? And that's okay. Right, so AB is our shortest side. Okay. All right. In reverse, the longest or the largest angle. Well, the largest angle must lie opposite the longest side. Right. So that means angle C must be the largest angle in this picture, and the smallest angle must lie opposite the shortest side. So angle B is the smallest. Easy peasy. Okay, here we go. Complete the following statements. Okay, so this is your R inequalities, kind of using that hinge theorem. So angle 1 and angle 2. Okay, well, angle 1, again, like we just talked about, angle 1 is creating a side length of 17, right? And angle 2 is creating a side length of 16. Well, you'll notice 17 is greater than 16, which means angle 1 must be greater than angle 2. I don't have any idea what their actual measurements are, but I know that angle 1 has to be bigger because his side length is longer. All right, same thing over here, just with the opposite concept, right? We're looking for side lengths, right? So the length of AT, right? Well, AT is being created using the 65-degree angle, right? And BT is being created by the 63-degree angle. And clearly 65 is greater than 63, which means AT must be longer. Okay, hinge theorem. All right, number 39. B is the midpoint of AD. All right, I'm going to stop right there. I'm going to mark that on my picture. All right, B is the midpoint, so I have congruency marks. C is the midpoint of AF. Okay, congruency marks. E is the midpoint of DF. Okay, I have more congruency marks. And the reason I'm putting the markings on here is to show that we have a lot of midpoints, and that means that BC and BE are mid-segments. Okay. All right, let's see. AD is 16. All right, if it's cool with everybody, if AD is 16, well, I'll just write it all out. You obviously don't have to write every single piece of this, because if AD is 16, then I already know that these are 8, right? And let's see, what else did they tell us? DF is 18, okay. So if DF is 18, but EE is a midpoint, then I know this is 9 and 9. And then AF is 20, okay. So AF is 20, which means these are 10 and 10. All right, oh my gosh, all that stuff. And let's see, all they wanted us to find out was BE. Well, BE is a midsegment, and that means he is not only parallel to AF, but he's also half of AF's measurement. Well, AF was 20, so BE is 10. Oops, let me not write in highlighter there. Oh my goodness. All that work for that one little tiny question. All right. The last one, can you make a triangle with the following 3 lengths? Well, this is our triangle inequality theorem that says the smaller, if you add the smallest two sides, their sum has to be greater than the third side. So let's see, these would be my smaller two. So if I add 6 plus 7, is that greater than 12? Put a little question mark there. And yes, right, 13 is greater than 12. Check mark, smiley face. So this is a yes. Okay, over here, my two smallest sides are 4 and 5. So I'm going to check to see if 5 plus 4 is greater than 9. And no, it's not, right? It is not greater than 9. It is equal to 9, right? So this is a big no, right? It has to be greater. All right, number 42, write an inequality that describes the possible lengths of the third side of the triangle. Okay. We didn't really talk about this in class, but I'm gonna do something really crazy, and you don't have to do this on your paper, but I'm going to make this problem uber long, and you don't have to do it this way. It's a shortcut, but I just want to explain why this works. Okay, 1, 2, 3, 4, 5. I'm just going to write a whole bunch of numbers down. Just bear with me here. Okay, I'm just going to stop at 20. Okay, so you're basically asking yourself, I'm going to go through every single one of these numbers and ask myself, could it be, right, if it was 11, 8, question mark, right, what could possibly, out of these numbers, which ones could be a side length to, or the third side of a triangle? Okay, so we're just using this. We're just using the triangle inequality theorem here. All right, so let's ask ourselves, could my third side be a 1? So could it be 11, 8, and 1? Well, no, because 8 plus 1 is only 9, and 9 is not greater than 11. Again, you can kind of do all that in your head, right? So I'm going to X this out. It cannot be 1, okay? Can it be 2? Well, no, because 8 plus 2 is 10, and 10 is not greater than 11. Can it be 3? No, but there is something special about the 3. So I'm going to underline him, right? I'm not going to circle him because he's a no-go, right? But can he be 3? No, because that would give me equals 11. And we just talked about that on the previous problem, that number 41. Okay, let's go to 4. Could he be 4? Well, yeah, now we're getting to some actual third side lengths that it can possibly be, right? So 4, because 12 is greater than 11. What about 5? Yes. 6, yes, because 14 is greater than 11. 7, yes, right, because 15 is greater than 11. 8, yes, because 16 is greater than 11. 9, now, once we switch to 9, now, right, now 8 and 9, oh, sorry, I got ahead of myself, right? 8 and 9 are my smallest sides. That's 17. 17 is greater than 11. Still good. All right, what about 10? Yep, 8 and 10. That's 18. It's greater than 11, so still good. What about 11? Yeah, 11 works because 11 plus 8 would be 19, and 19 is greater than 11. All right, what about 12? Now, something weird happens when I put 12 in here as the question mark, right? Because now 12 is the biggest side. So now it's 8 plus 11 that I'm checking, right? So 8 plus 11 is 19. Is 19 greater than 12? Yeah, so 12 still works. What about 13? Yes. What about 14? Yes. 15? Yes. 16? Yes. 17? Yes. 18? Yes. All right. 19. 19 is going to be a problem, right? Because if I do 8 plus 11, right, that is not greater than 19. It's equal to it. So I'm going to underline it kind of like that 3 that we did earlier. And then notice if we do 8 plus 11 is greater than 20, that's not true. So now I'm going to start getting into the realm of all the numbers that don't work. okay? I know this is a long explanation, just bear with me. All right, so look what's happening. Do you notice how I was like, no, 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 and then all these yeses, and then I entered the realm of no again. So clearly, my third side can be anything from 4, oops, I didn't mean to do that, anything from 4 all the way up to 18, right? But the question is, what about 3.5? Right? I didn't put any decimals in my little mix here, right? What if I put 3.5 in there? Would that work? Right? And yeah, it would, because 8 plus 3.5 is 11.5, and 11.5 is greater than 11. So even though 3 didn't work, you need to recognize that any of the decimals above 3 do work. Even like 3.00001, right, would work, right? But just not 3. So it's everything greater than 3, but less than 19. Because would 18.999 work? Yeah, because 19 is greater than 18.999, right? So I can use every number between 3 and 19. And that is the inequality we're going to write to represent all the possible lengths of that x could be. Okay, I'm going to copy that, put that over here. All right, I hope that makes sense. I'll talk about it in class too. Anyway, oh my goodness, that was a lengthy review. All right, and technically, I guess I should, sorry, I'm going to go back to this one. I should put yards on here, so I have like my little units of measure. So 3 yards to 19 yards, anything in between, but just not 3 and 19, so we don't put the equal to bar. Okay. All right. That should do it, you guys. I hope that helped. If you have any other questions, obviously feel free to ask in class or come in for tutorials, and I'd be more than happy to help you out. All right. Happy studying.